Hello students, today we're going to learn section 4.2, Triangle Congruence using SSS and SAS. In section 4.1, in order to prove triangles or polygons were congruent, we had to state all parts, all angles, and all sides. In 4.2, these two theorems allows us just to provide three congruent parts. Either side, 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 or side, angle, side. So the first one is SSS, side, side, side. So when we look at these two triangles, triangle ABC and triangle YXZ, AB, side AB is congruent to side XY. So AB is congruent to XY. Because we have one congruent mark matched up with this congruent mark. BC is congruent to YZ. Two congruent marks match with these two congruent marks. That's why we know these sides are congruent. And the last one is CA is congruent to ZX. Three marks, so these two sides are congruent. So if we have side, 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 then we can claim that triangle ABC is congruent to triangle XYZ without naming the other parts, the angles. And remember to put your proof sign that you're done. All right, next is SAS. So SAS means side, angle, side. Now, it cannot be any angle. It has to be the angle included. So angle included means it has to be between the two sides that are congruent to each other. So here is an example. So we have triangle DFE and triangle UWV. We'll say that angle DF is congruent to angle UW. It's given. 2 marks, 2 marks. Angle D is congruent to angle U. 1 congruent mark, 1 congruent mark. And angle DE is congruent to angle UV. 1 congruent mark, 1 congruent mark. So if you have what we call a side, angle, side, the angle has to be between the two sides that are marked congruent. Then we could use the SAS theorem to state that triangle EDF is congruent to triangle VUW. And again, these are corresponding parts. Here's D and U. Second position, second position. We said DF is congruent to UW. DF, UW, second, third, second, third. We said also DE, second, first is congruent to UV, second, first. Order is very important when we do these proofs. Okay. Now let's do an example. All right. So here's our diagram. They say M is the midpoint of XY. They also say that AX is congruent to AY. Prove triangle AMX is congruent to triangle AMY. So this triangle is congruent to this triangle. We have to come up with a two-column proof, statements, and reasons. Well, they say AX is congruent to AY. AX is congruent to AY. That's given. We also know that XM is congruent to YN. The reason is definition midpoint. Remember, midpoints cut segments in half. So if you want to mark it now, go ahead and mark it now. But again, the reason is definition of midpoint, not given. This was not given to us. We had to know definition of midpoint. And we also can see that side AM is equal to side AM itself. That's a reflexive property. If you want to just mark this. So now we have all three sides congruent to all three sides of both triangles. If you have that, we can claim that triangle AMX is congruent to triangle AMY. So AMX congruent to triangle AMY. By side, side, side. You are done. All right, next page. So let's look at example 2. Example 2, it says given angle RSG is congruent to angle RSH. Also they say side SG is congruent to side SH. So SG is congruent to SH. They say angle RSG trace RSG is congruent to angle RSH. Well, now, again, instead of naming all 6 parts of each triangle are congruent to each other, we just have to either use SSS or SAS. Well, we're going to use SAS because we have a side and angle. Also, I know that RS is equal to itself. So RS is congruent to RS, the reflexive property. Well, look what we have here. We have a side, we have the angle, and we have another side. Notice the angle is between the two sides that are congruent. So the angle cannot be here. That would not be SAS. So it has to be side, angle, side. Side, angle, side. So if we have a side, an angle, and a side, then we can use the SAS theorem to state our proof. Triangle RSG is congruent to triangle RSH. The proof line will always be your last line when it comes to 2-column proofs. All right, in example 3, the directions are what other information is needed to use SAS and SSS for triangle ADC to be congruent to a triangle BCD. So this is not a 2-column proof. It's just asking what information do we need to make these 2 triangles congruent using SAS and then using SSS. So let's take a look at the SAS case. We know that AD is congruent to BC. That's given. We also know that DC is equal to CD. DC is equal to CD. That's a reflexive property. So again, if you focus on this triangle versus this triangle, what we need is we need this angle to be congruent. So that's what we need to make these two triangles congruent using SAS. So angle ADC has to be congruent to angle BCD. So angle ADC has to be congruent to angle BCD. So this is what's needed in order to use SAS. Side, angle, side. side, angle, side. So again, side, angle, side. Look at this triangle. Look at this triangle versus this triangle. Okay, so now let's figure out what information do we need SSS. Well, we know AD is congruent to BC, that was given. DC is congruent to CD, that's reflexive. So the only part we need is AC to be congruent to BD. So we need side AC to be congruent to side BD. So this is what's needed in order to make our SSS case. Okay, and again, remember, order is very important. So AC congruent to, don't put DB please. It's important you put in order. AC, first, third. BD, first, third. AC, first, third. BD, first, third. Order, again, is very important. All right, that's it for today. Thank you.